Right, so in today's lesson 1.6, we're going to be looking at our final definitions, which are in quadrilaterals. We'll continue with our discussion in lesson 1.6 next week, but for the most part, we're trying to do is lay a foundation for what are the special quadrilaterals, which we've talked about some of them at this point. What are their definitions, and then what is a connection between building these quadrilaterals using some triangles, which will be the latter part of this activity. So we'll start off by what is quadrilateral, and then I'd like you to do is what's your definition, and then I'd like you to look at the pictures that are provided, and I'd like you to write the definitions for these shapes. Again, some of them we've already talked about, so hopefully at least half of them you might be able to quickly write just based on our conversations for the last periods. Turn the video back on when you're ready to check your definitions, and again, I'll provide some additional information for each of the terms. All right, so a quadrilateral is a polygon. We talked about polygon in the last lesson. And what does it have? It has 4 sides. So all the shapes we're going to talk about today are polygons that have 4 sides, and each of them has something that's unique, which gives it the name they have. So a kite is a quadrilateral because it does have 4 sides. Then has 2 adjacent sets of sides. That are equal. But each set is different. I mentioned in our last discussion, or early discussion, that 2 words are really hard to describe or define. Polygon, because you got to make sure that you're not creating that counterexample, and a kite is the other one. I think it's really hard to define a kite, so it's very easy to draw one and mark one, but to make sure the definition is clear. So there are 2 sets of sides that are equal. So this has 2 sets of sides are equal, this has 2 sets of sides are equal, as well as this one here has 2 sets of sides are equal. But each set is different. And by saying that each set is different, what we are eliminating is that a rhombus and a square cannot be a kite. Because if each set could be the same, then we'd have a rhombus or a square. So that's what we're trying to avoid here is the rhombus and square being the special type. Trapezoid also is a quadrilateral. That has only 1 set of parallel sides. This is probably of all the definitions one of the more controversial for textbooks, because some textbooks will take the word only out and just simply say 1 set of the parallel sides and allow parallelograms to be special trapezoids. But in your textbook, the word only is critical. So parallelograms, squares, rhombuses, and rectangles cannot be special trapezoids. A parallelogram is a quadrilateral that has 2 sets of parallel sides. So hopefully if you look at the definitions here, so all of the trapezoids have only 1 set of parallel sides. The arrow heads are what we use for parallel. And for parallelograms, there are 2 sets of parallel sides. All right, so beginning with rectangle, if you look at the next three definitions, you will notice that all of the shapes actually have two sets of parallel sides. And the reason why they're marking the shapes this way is because they don't want you to say that these shapes belong in the quadrilateral family. They actually want you to say that these shapes all belong to the parallelogram family. I know for the last couple of class periods we have been calling them quadrilaterals because they are. And some textbooks will actually define them as quadrilaterals. But your textbook, we are defining them as special parallelograms, and then within the parallelogram family, each of these shapes have something that's unique. So for a rectangle that has four equal or four right angles. For a rhombus, it's a parallelogram, then you get two sets of parallel sides that has four equal sides. And for a square, it's a parallelogram that has, as we defined, four equal sides. And four equal angles. So the only difference in these definitions and when we defined them previously is that instead of calling them quadrilaterals, we're calling parallelograms for your textbook. Now, isosceles trapezoid is a quadrilateral, and it happens to be a special trapezoid. So an isosceles trapezoid is a trapezoid. And what's unique about an isosceles trapezoid is that it does have one set of parallel sides, and it also has one set of equal sides. That's not the parallels. That has one set of equal sides. And again, the sides that are equal are not the parallel sides. And by making sure that we don't clarify the parallel sides are not equal here, then we are eliminating some other shapes that could possibly show up, such as maybe a rectangle or a rhombus or a square. But if I could make the sides I circled there equal, but also make the parallel sides equal, then all of a sudden I may have a parallelogram, and I might have a rectangle, rhombus, or a square. So again, these trapezoids are not parallelograms, they're not rectangles, rhombuses, or squares. All right, so this is kind of the investigation. And in the last page, we have two sets of triangles. You have two isosceles right triangles, two equilateral triangles, two scaling rights, and two scaling obtuse. And what you're trying to do is you're trying to put two of the triangles together in such a way that they're sharing an edge. So we're not doing a point-to-point like an hourglass. But we're doing two edges, two sides, trying to make a quadrilateral out of the shapes. And what we're trying to figure out is, can you make a trapezoid using the same two triangles? So again, it's critical that you use two triangles that are the same triangle. So we're going to use both isosceles right at the same time, or both scaling right triangles at the same time, and so on. And is it possible to make a trapezoid? Is it possible to make a kite? And we're going to be looking at the other shapes, like a parallelogram, square, rectangle, and a rhombus. And at least one of these quadrilaterals is not possible. You cannot build them using the same two triangles. So all you do is try to build a shape that fits the definition. So make sure, for example, if it's a kite, that you have two sets of adjacent sides that are equal, but the two sets are distinct or not equal to each other. If it's a parallelogram, make sure that the shape looks like they have opposite sides being parallel. If it's a rectangle, make sure that the four angles are right angles. And again, part of this will be a visual thing in terms of put the two triangles together. Do they really make four right angles? So let's go ahead and cut the triangles out. And I'm going to encourage you to turn the video off. And then when you're ready to begin, let's jump down to the activity that involves the rectangle. And can you figure out which two triangles put together would make the rectangle? And what I'd like you to do is you can trace the two triangles on the paper. And I know the triangles are kind of large, but that might be one way of kind of getting a really nice outline of it. Or you can just kind of sketch it onto the paper itself, and then check off which triangle did you use. So cut the pieces out, work on the rectangle, turn the video back on when you're ready to continue. So for the rectangle, if you use the scalene right triangle, and put two of those together like this, what you would end up with is a rectangle. So this would be the example of the rectangle. Now the isosceles right triangle, that would make sense that would be the rectangle, but because it is an isosceles triangle, that triangle might actually produce one of the shapes that has equal sides, since the two sides of the triangle happen to be the same. So this would be the example of the rectangle. For the triangles, this is the only triangle that we can actually use to make the rectangle. In some cases, you may find that there's more than one way to make the shape, and we'll talk about that on Monday when we meet next. So that would be the rest of this activity. So when you finish with determining the shapes at work, if you might at least one of them doesn't work, then the rest of the time is yours to work on the homework assignments. You should have Mixmaster 2, 3, and 4 now. And so if you need Mixmaster 2 and 3, they are on the metal cabinet. And if you need Mixmaster number 4, your teacher will be distributing to you today. Also, make sure you get the materials, a ruler and a protractor to help you with those activities.